Hello guys, I'm Karthik SP from SVC and today my topic is joint dependency and fifth normal forms and example of fifth normal forms and the subject is database management system and let's start joint dependency introduction part. So first joint dependency are these are the concepts in the field of relational database theory that go beyond traditional functional dependencies are a fundamental concept in database design, describing the relationship between attributes in a relation. Joint dependency come into play when dealing with relations that are not in fully normalized forms. Say semi-joint dependencies. A semi-joint dependency expresses a condition under which a certain attribute in one relation can be reconstructed by the other. Its essential constraints are a set of attributes in a relationship that can be derived by joining with other relations. Later is anti-semi-join dependencies. This specifies a condition under which a certain attribute in a relation can be constructed by joining it with other relations. It represents a constraint on a set of attributes in a relation that cannot be derived by joining the other relations. Later, explanation of joint dependency. Joint dependency, these are the concepts in which a relation database theory that extends the idea of functional dependency to handle constraints. In a relation database, tables are linked through common attributes, and join operations are used to combine tuples from different tables. While functional dependency captures relations within a single relations, joint dependency describes constraints and on the combination of tuples can result from joining multiple relations. Later, extension of functional dependency. Functional dependency describes relations between attributes within single relations are expected as A arrow B, comma, meaning that the value of attributes B is functionally determined by the value of A. Later is the functional dependency. Have attributes within a single table and related, whereas joint dependency deals with how attributes from different tables are related from those tables are joined. Later is the joint dependency notations. R1, R2, Rn are the relation involved in the joints. Next, natural joint operations. P is a predict that defines that condition under which the joint dependency holds. The notations used to represent joint dependencies, like 1, comma 2, comma R1, comma R2, so on up to Rn are the relations involved in the joint. P predicts or conditions that specify the joint dependency. Consider three relations: 1 R1, 2 R2, and 3 R3. Suppose we have relations X, Y, and Z. Scope functionality dependency involves relation within a single relation or a table. Joint dependency involves relation across multiple relations or tables. Representations typically represents arrow X, arrow Y, where the values of Y are functionally dependent on the value of X. Represented using set notation such as P, where P is a condition showing joint dependency. Later, dependency type FT describes dependency within a single table, such as changing the value of one attribute uniquely determining the value of another. JD describes dependency involve the combination of tuples from relations from those relations are joined. Dependency types use case scope representations FTJD used for normalizing purpose and maintaining data integrity. JD designing complex data schemes and involving multiple tables, clarifying the difference between joint and functional dependency. Scope functional dependency deal with dependency within a single relation or table. Joint dependency addresses dependency involving multiple relations or tables. FT typically represents X arrow Y, indicating that the value of Y are functionally dependent on the value of X. JD represents where set notations like P, where P is a condition specifying the joint dependency. Dependency type FT describes how changing the value of one attribute determines the value of another. JD describes dependency involving the combination of tuples from different relations. Use case FT primarily used for normalizing and maintaining data integrity within individual database. JD used in complex database designs where tables are joint capturing relations. Instances where joint dependency captures constraints that functional dependency cannot. Non-first normal forms, if tables are not in 1F, 1NF functional dependency alone might not capture the relations. End-to-end relationships, hierarchical or network data models, aggregating and partitioning. Functional dependencies are limited in representing many-to-many relationships between tables. When dealing with hierarchical or network data models, where information is spread across multiple tables with complex relationships, joint dependencies provide a more expression way to capture aggregation and partitioning. In cases where data is aggregated or partitions across tables, joint dependency can be better express the constraints or how aggregated partition values are related. Later is the fifth normal form is an advanced level of normalization in relation database design. In 5NF, a relation is in the normal form if and only if it is N4NF, and additionally it can be decomposed into smaller relationships without losing some non-trivial joint dependencies. Definition purpose of 5NF: understanding its roles in addressing certain types of complex dependency, overlapping of joint dependency. So definition purpose um, is an advanced level or normalization in a relation database design. Purpose, primary purpose of INF is to eliminate certain types of redundancies and anomalies that might persist even after a database has been brought into 4NF. Role in addressing certain types of complex dependencies. Handling multiple value dependencies. 5NF plays a crucial role in addressing multi-valued dependencies that might still exist even after the application of normal forms. Dealing with non-trivial joint dependency, 5NF focuses on eliminating redundancies while maintaining non-trivial joint dependencies, ensuring lossless joint decompositions. One key attempt of 5NF is the requirement that decomposing should not result in a loss of information. Support for complex data models in scenarios where the data model is complex, involving tables and intricate dependency. 5NF provides a framework for maintaining a highly normalized and well-structured database. Overlap joint dependency, 1, 2, R1, R2, so on up to Rn. Predict specifying the joint conditions. Q predict specifying the conditions under which people should not overlap. Later is the explanation of situation where candidates key overlaps to joint dependency. How 5NF addresses these cases, 5NF and decompositions. Shared attributes, two or more relations share common attributes, and these attributes collectively form candidates. It results in an overlap of candidate keys. Shared attribute across relations, interconnected relations. If the candidate's keys or one relation may involve attributes that are also part of candidate's key in another relation. Multi-value dependencies can contribute to overlapping candidates' keys when certain attributes participate in the keys of multiple relations and the values exhibit dependency on each other. How 5NF addresses these cases: non-trivial joint dependency ensures that these relations in both normal form before proceeding to a 5NF. Lossless joint dependencies emphasize the importance of lossless joint decompositions. 5NF provides a framework for handling complex dependencies, including situations where candidates key overlap. Overlapping key candidates can lead to redundancies. 5NF aims to eliminate these such redundancies. 5NF and decompositions is 5NF to bring a relationship to 5NF undergoes a decomposition process. Preserving joint dependency ensures that the decomposition maintains non-trivial joint dependencies. Lossless joint dependency is key requirement to in NF. If candidate key overlaps between relationships, the decomposition process in 5NF addresses by ensuring that the resulting tables maintain integrity of these keys. Techniques for decomposing a relationship into 5NF. Example scenarios demonstrating the application to 5NF. Examples of normal forms. First normal form examples. Technique for decomposing a relationship with a 5NF. Identifying non-trivial joint dependencies. Use lossless joint dependencies. Considering overlapping candidate keys. Analyzing the dependency between the attributes of the relationships. Decomposing the relationships in a way that ensures lossless joints. Candidates key overlaps carefully, choosing the decomposed strategy to preserve the integrity of these keys. Analyze dependency across tables, evaluating the dependency that span multiple tables after decomposition. Analyze the dependency across tables. Decomposition to 5NF. Plus, since the dependency arrow is a non-trivial that multiplies Attributes relations can be decomposed into two tables, table as well as both tables maintain normalized 1NF relations, student table attribute data, course table attribute data, detailed examples illustrating how to convert non-1NF relationship into 1NF, emphasis on atomicity to attribute values, second normal form examples. Examples converting a non-1NF relationship into 1NF. Step 1, identifying the repeating groups. The course attributes contains multiple values for each student, forming repeating groups. Identify the composite key, remove partition dependency. Practical scenario showcasing the removal of partial dependency, transforming a relation into an third normal form example. Practical scenarios, removal of partial dependencies. Let us consider a practical scenario involving a relationships that transform into second normal form. Suppose we have a database like tracking employees in information including projects that are assigned to project details and hours worked on each project. Later is identifying composite keys and partial dependencies. A composite keys is partially dependent on the composite key. Step 2 removes partial dependency, third normal form for examples. Later is a transitive dependency. It's transitively dependent on employee ID as employee name is functionally dependent and normal ID as a part of composite key, remove transitive dependency. In-depth example highlighting the elimination of transitive dependencies, decomposing a relationship to 3NF boys called normal form examples. In-depth example explanation of transitive dependencies and decomposing it in 3NF. Considering a scenario where relation describing information about employees, these departments and the project they work on. Step 1, identify composite keys and transitive dependencies. Department is transitively dependent on employee ID. Removes transitive dependency by called normal form examples. Identifying superkey and non-trivial dependencies. Superkey, non-trivial dependencies, and textbook names are functionally dependent on the superkeys. Later is decomposing to BCNF, a case study demonstrating the application of BCNF focusing on scenarios where BCNF is necessarily beyond 3NF multi-value dependency examples. Case study applying BCNF and beyond, involving a university database that tracks the information about professors, courses they teach, and classrooms they use. Original relationship includes attributes that professionally detail course details and classroom details. Original relations, professors, course, classrooms. Professors can teach multiple courses. Professors can use different classrooms for different courses. Later is the issue beyond 3NF. Is in 3NF as their non-transitive dependencies. Is a dependency between that goes beyond 3NF. Superkey non-trivial dependency is functionally dependent on the superkey. Step 2 decomposes into BCNF. Relationship is now in a BCNF and each table represents an independent entity. Decomposing ensures that each table has a single, this eliminates non-trivial dependencies. If there is a multi-value dependency, BCNF might still be enough. For example, if a processor can multiple classrooms or a single course, or if there is a scenario where certain a combination or determines multiple sets. Multi-value dependency examples. Explanation of multi-value dependency, a real-world example illustrating normalization process with MVD fourth normal form examples. Later is the multi-value dependency part, real-world examples of normalization with MVD. Plus is a combination of professors and courses uniquely determines the textbooks used. Multiple textbooks for the same professors and course MVD superkey. Decomposed into 4NF. Instances where 4NF is necessary, decomposing a relationship into 4NF, domain key normal form examples. Instances where 4NF is necessary, involving the same set's attributes for 4NF might be necessary to address these dependencies. Complex relationships where certain combination of attributes determine multiple set of values from other attributes. 4NF is required to avoid redundancy and maintain data integrity. Complex relationships, 4NF can be beneficial in optimizing storage and query performance. by breaking down large tables into smaller, more manageable tables with fewer dependencies. Decomposing a relationship into core NF. Arrow MVD plus of step to decomposing into core NF. Domain key normal form examples plus of decomposition DK bar NF. Overview of DK bar NF and its significance. Application of DK bar NF in a database design scenarios. Overview of domain key normal form and its significance and significance of DK bar NF. Addressing domain dependencies. Mm, Certain attributes are functionally dependent on a specific domain or a set of values. Consider key dependency. DK bar F incorporates a key dependency that the primary keys are candidates or relationships that are explicitly defined and maintained. Avoid redundancies by addressing both domain and key dependencies. DK bar NF helps eliminate redundancies in the database schemes, leading to leading to a more compact and efficient relationships or data. Later is the overview of DK bar NF and significance. Well-designed database is a DK bar NF that can lead to more efficient query performance that minimizes the need of complex joins and unnecessary duplications. Application is a database scenario. Later, discussion on preserving original dependency during decompositions. Preserving original dependency property ensures that the original information can be reconstructed through normal joins. Later dependency preservations are represented in the decomposed tables. Normalized algorithms are like third forms, boys called normal forms and higher normal forms. Normalization best practices. Understanding the data model, step-by-step approach, balance between decomposition and performance, document dependency, regular review. Normalization best practices, testing and validation. Understanding business requirements, start with normal forms. Identifying dependency within the database sets. Identifying functional dependency, like avoid redundancy as well as use primary and candidate keys, balance normalization and performance. Document dependency, documents all are identified within during the design phase. Later is the document dependencies. In that we can have approach of review and iterate as well as consider denormalization when necessary. First normal form, second normal form as well as third normal form. Boise got normal forms, non-trivial dependencies into super keys. Fourth normal forms, multi-value dependencies. Fifth normal form, cases when joint dependency exists. Domain key normal form, appropriate when addressing. So this is the end of this slide. Thank you. Have a nice day. Bye.